Alright, so in this problem, I have x to the power of x is equal to 2 to the power of 2048. So I want to find the value of x here. So for my solution, I first start with x to the power of x is equal to 2 to the power of 2048. Now, I'm actually going to rewrite 2048 here as 2 to the power of 11. So now I have x to the power of x is equal to 2 to the power of 2 to the power of 11. Now 2 to the power of 11, that's the same thing as 2 to the power of 10 times 2 to the power of 1. And that's also the same thing as 2 to the power of 2 times 2 to the power of 9, which is the same thing as 2 to the power of 2 to the power of 3 times 2 to the power of 8. And now, well, 2 to the power of 3, that's simply equal to 8. So now I have x to the power of x is equal to 2 to the power of 8 times 2 to the power of 8. And now, if I have something in the form a to the power of m times n, this is simply equal to a to the power of m to the power of n. So in this case, this can equal 2 to the power of 8 to the power of 2 to the power of 8. Now, if I have something in the form a to the power of a is equal to b to the power of b, then this means that a equals b. So in this case, x is equal to 2 to the power of 8. So this is my answer to this problem. Alright, so in this problem, I have 9 to the power of x plus 15 to the power of x is equal to 25 to the power of x. So the first thing I'm going to do is I'm going to divide both sides by 9 to the power of x. So now I have 1 plus 15 to the power of x over 9 to the power of x is equal to 25 to the power of x over 9 to the power of x. Now it's the same thing as 1 plus 15 over 9 to the power of x is equal to 25 over 9 to the power of x. Now 15 over 9, that's going to be simplified to 5 over 3. And 25 over 9, we can rewrite 25 as 5 squared and 9 as 3 squared. So now I have 5 squared, 3 squared to the power of x. Now, I can write 5 squared over 3 squared as 5 over 3 to the power of 2 to the power of x. And I'm actually going to switch the places of these two. So this is going to be to the power of x to the power of 2. Now I'm going to let 5 over 3 equal to the variable, I'm going to let 5 over 3 to the power of x equal to the variable y. So now I have 1 plus y is equal to y squared. Now I'm going to subtract y and 1 on both sides, so now I have y squared minus y minus 1 is equal to 0. Now I'm going to go ahead and factor this. So I'm going to use the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, a is equal to 1, b is equal to negative 1, and c is equal to negative 1. So now I have y is equal to negative of negative 1 plus or minus the square root of negative 1 squared minus 4 times 1 times negative 1 all over 2 times 1. And now this simplifies to 1 plus or minus the square root of 1 plus 4 over 2, which is equal to 1 plus or minus the square root of 5 over 2. So now remember how we set 5 over 3 to the power of x equal to y. So if y equals this, then I have 5 over 3 to the power of x is equal to, let's first start with 1 plus the square root of 5 over 2. So to solve this, I'm going to go ahead and take the log on both sides. Now I can move this exponent to the front, so now I have x times log 5 over 3 is equal to log 1 plus the square root of 5 over 2. Now if I divide both sides by log 5 over 3, These two cancel out, and I'll be left with x is equal to log 1 plus the square root of 5 over 2 over log 5 over 3. Now, for 1 minus the square root of 5 over 2, I have 5 over 3 to the power of x is equal to 1 minus the square root of 5 over 2. Well, 1 minus the square root of 5, that's going to be a negative number. And you can't take the exponent of a positive number and make it a negative number. So this is wrong, and this is my only solution. Alright, so in this problem, I have x minus 4 to the power of 4 is equal to x to the power of 4. So to solve this, I'm going to first start by subtracting x to the power of 4 on both sides. So these two cancel out, and now I'll have x minus 4 to the power of 4 minus x to the power of 4 is equal to 0. Now, I can rewrite x minus 4 to the power of 4 as x minus 4 squared to the power of 2. And I can rewrite x to the power of 4 as x squared to the power of 2. Now, if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. In this case, a is equal to x minus 4 squared, and b is equal to x to the power of 2. So now I have x minus 4 squared plus x squared times x minus 4 squared minus x squared. This is equal to 0. Now, x minus 4 squared, if I expand that, I get x squared minus 8x plus 16. Now I have this plus x squared times x squared minus 8x plus 16 minus x squared is equal to 0. Now for my left-hand side, these two cancel out, and for my right-hand side, these two add up. So I get 2x squared minus 8x plus 16 times negative 8x plus 16 is equal to 0. So now this gives me two equations. I have 2x squared minus 8x plus 16 is equal to 0, and I have negative 8x plus 16 is equal to 0. So for negative 8x plus 16 equals 0, I simply add 8x on both sides. And I get 16 is equal to 8x, meaning x is equal to 2. So this is one solution of x. Now for 2x squared minus 8x plus 16, you can first start by factoring out 2. So I get x squared minus 4x plus 8, which is equal to 0. Now I can just take out this 2 by dividing both sides by 2. So now I have x squared minus 4x plus 8 is equal to 0. So to solve this, I'm going to use the quadratic formula. And I'm actually not going to waste your guys' time by actually solving this, because that's going to take a while. But you do end up getting x is equal to 2 plus or minus 2i. So if you use the quadratic formula, this is the result that you should get. So these are my three solutions to this problem. My first solution is x equals 2. My second solution is x equals 2 plus 2i. And my third solution is x equals 2 minus 2i. So these two solutions are imaginary, and I have one real solution.